Rock coring. To understand what rock coring is, let's first define its terminology. So what is coring? Coring is the process of recovering cylindrical cores of rock by means of rotating a hollow steel tube equipped with a coring bit. The drilled core is carefully collected in the core barrel as the drilling progresses. After successfully defining what coring is, let's discuss its significance and its uses. First, rock cores are samples of record of the existing subsurface conditions at given borehole locations. Next, from the collected samples, these conditions, like its geological, physical, and engineering nature, are vital for the design and construction of a structure. Lastly, rock cores always need to be handled in such a way that their properties are not altered in any way due to mechanical damage or changes in ambient conditions of moisture. This is the typical setup for rock coring. Drilling is accomplished by circulating a drilling medium through the drill bit while rotating and lowering or advancing the string of drill rods as downward force is applied to a cutting bit. The bit cuts and breaks up the material as it penetrates the formation, and the drilling medium picks up the cuttings generated by the cutting action of the bit. The drilling medium with cuttings then flow outwards through the annular space between the drill rods and drill hole, and carries the cutting to the ground surface, thus cleaning the hole. The string of drill rods and bit is advanced downward, deepening the hole as the operation proceeds. Outputs like this are expected once the core has been cut and the barrel is full. The drill rods are pulled and the cores are retrieved. Outputs are then labeled using the rock quality designation or the RQD. It is an index to measure the quality of a rock mass used by many engineers. RQD is computed from samples as the summation of lengths of intact pieces of core which are greater than 100 mm over the length of core advance or the total length of the core. There are no fast rules for the depth of rock cores. Generally, one should core approximately as follows. First, a depth sufficient to locate sound rock, or to ascertain that it is fractured and jointed to a very great depth. Second, for heavily loaded members such as piles or drilled piers, a depth of approximately 3 to 4 meters below the location of the base. The purpose is to check that the sound rock does not have discontinuities at a lower depth in the stress influence zone and is not a large